Good morning. My name is Somnapriya, daughter of Ramanathan. I am from Polymas, Polytechnic Sultan Abdul Halim Azam Shah. Today I would like to present about the development of dual-axis solar tracking system to optimize solar panels output. We start with the introduction. In this research, we propose a prototype that is dual-axis solar tracking system which absorbs sunlight precisely and gives us a maximum output as an electrical energy. We also compare our dual-axis solar tracking system with the stationary PV panels to convey the output of our project. These are the objectives of our research. Firstly, to design a structure for dual-axis solar tracking system. The second is we want to analyze the performance of the dual-axis solar tracking system compared with the stationary panels, and then to develop an archetype that able to make the solar panel to track the sun path. Lastly, to gain more heat during the sunny weather to produce maximum power output. From this slide, we can see the problem statement of our research. Firstly, the stationary solar panels only produce maximum power output at certain time when the sun is directly on top of that solar panels. The second is these stationary solar panels are taking a lot of solar area farming to generate electricity. The third is seasonal changes that normally happen in Germany, China, Russia. This will bring a noticeable difference in both azimuth and zenith angle in the sun path. The third and the last one is compared to others like single axis trackers and then the stationary panels, lower energy output during sunny condition when compared to dual axis trackers. From this slide, we can see the scope part, and there is a project is divided into two major parts, which is software part and hardware part. For the software part, we use IDE software to write the source code for Arduino Uno R3 board, and then for the hardware part, we both comprises both electrical and mechanical hardware. There is LDR sensors, Arduino board, and panel adjustment is used to change the panel position. For the mechanical part, a solar panel is carrier is using for moving both X and Y direction. Information from the software part Arduino, the servo motor in the mechanical part will be used to track the sun path. From this slide, we can see the general and technical flowchart. From the general flowchart, we can see the overall project working procedure, how it works. And from this technical flowchart, we can see that how the solar panel works when the sunlight changes happen in sunlight. From the general flowchart, we can see that we begin with the design and understanding of dual-axis solar tracking system, and then we design a software code. After it meets expectation, we done the hardware and electrical mechanical part. After it achieved analysis of dual-axis tracker with the static panel, it done successfully, and then the project report and presentation will be the end. For the technical flowchart, we can see that the tracker is in the rest mode. After there's a changes happen in the sun path, check the presence of the sunlight. If there's any movement, then it start to read according to the source code. Read the analog voltage of LDRs. According to the source code, the Arduino do the arithmetic. After the Arduino done the arithmetic, the result will be sent to the servo motor, and then the servo motor will help to move the solar panel according to the sun path. As I said, when the receive the signal, the motor will reposition the PV panels accordingly. The PV panel can access in both axes, Y and X, which is vertical and horizontal to face the sun directly. From this slide, we can see the flow of the project. Firstly, we separate the LDR into 4 positions, We use 4-quadrant separator to divide the LDR into 4 quadrants so that there will be a shadow will fall on the LDR surface whenever the sun moves as the LDR resistance change. When the resistance change, it will send signal to the Arduino. After the signal sent to the Arduino will start to do the programming according to the coding. After it's done the arithmetic, then the Arduino will send the signals to the servo motor to change the movement towards the sunlight. In this project, we use Arduino Shield because Arduino Uno R3 is unable to operate the 2MG995 servo motor since its current limited. So we use the Arduino Shield to require to operate the 2MG995 motor and supply power to Arduino Shield so it will power Arduino Uno R3 as well as servo motors. After that, the Arduino operates servo motor by sending PWM signals to minimize the difference between the LDR sensor input. If there is a difference, the motor will move according to the signal that's sent by the Arduino. If there is no movement, there will be no if there is no difference, then there will be no movements. From this slide, we can see the results for both stationary and dual tracker. We use the output as a graph, output current, output power, and output voltage. For the output current, the stationary is only get maximum output at 1 o'clock, but for the dual tracker, it's already start to get maximum output at 10:30. For the output power, the stationary is also start at 1 o'clock, but the dual tracker is already start to get the maximum power output at 10:30. Lastly, for the output voltage, the stationary is start to get the maximum output voltage at 12:30, but for the dual tracker, it already start to get the maximum output voltage at 11 o'clock. These are from this part we can see that we use multimeter to figure out the voltage and ampere. We took the result in different time period. At 2:30 p.m. the voltage is 5.16 voltage and then the ampere is 0.35. At 3:30 p.m. the voltage become 5.02 and then the ampere become 0.33. After that, at 4:30 p.m. the voltage become 4.78 and then the ampere become 0.30. From this slide, we can see the project image. We design in 2D and 3D, and the last picture is the model of our research. From the last slide, we are about to discuss about the conclusion. The conclusion is the development of an performance of this dual-axis solar tracking system is more methodical in terms of the electrical energy output compared to these stationary or fixed PV panels. The design that we propose, followed by that our objective, is to prove that the dual-axis solar tracking system is really entailed and it works precisely in 4 season countries, as I said before, like Germany, China, Russia, and the others. Since the solar power technology is purely eco-friendly, it should be constantly advancing and great improvements will intensify in the future. Thank you for listening to the presentation.